Hello everyone. We will now work on the next set of problems in Project 1, and these have to do with the different identities that we learned in trigonometry. Question number 6 says, use your knowledge of special angles to answer the questions below. Find the value of the trigonometric function cos of 2 pi over 3 and cos of negative 2 pi over 3. Now, as you can see, the angle measures are the same. One is, however, a positive angle. The other one is a negative angle. So when the value of the angle is the same, but one is a positive value and the other one is a negative value, we can apply the odd-even properties of functions that we learned before. Now, cosine is an even function. What does that mean? That means the cosine of a positive angle will have the same ratio as the cosine of a negative angle and vice versa. Therefore, cos of x will be equal to cos of negative x for every angle x. Cos of negative x will have the same value as cos of x. That is what the even property states. So in this case, x given to us is 2 pi over 3. So cos of 2 pi over 3 will be equal to cos of negative 2 pi over 3. However, 2 pi over 3 is an angle in the second quadrant. So if we draw our angle, then positive 2 pi over 3 will be an angle in the second quadrant. This is 2 pi over 3, whereas negative 2 pi over 3 will be a third quadrant angle. A negative angle is formed by moving in the clockwise direction, so it'll be somewhere here in the third quadrant. So this is negative 2 pi over 3 and the blue angle is positive 2 pi over 3. Now for both of them, we can find their reference angles. So 2 pi over 3, since it's a second quadrant angle, we can find its reference angle by subtracting 2 pi over 3 from pi, correct? So that's pi over 3. Therefore, cos of 2 pi over 3 will be the same as cos of pi over 3, but it's going to be negative cos of pi over 3 because cosine in the second quadrant has a negative ratio, correct? And in the third quadrant as well, cosine has a negative ratio. So cosine is negative in the second quadrant as well as in the third quadrant, correct? So we are going to find cos of pi over 3 and make the ratio negative. And that's what we've done here. Cos of 2 pi over 3 equals negative cos of pi over 3, which is equal to negative 1/2. Cos of pi over 3 has a ratio which is half. So cos of 2 pi over 3 will be negative 1/2. And cos of negative 2 pi over 3 will also be equal to cos of 2 pi over 3, which is negative cos of pi over 3, which is equal to 1/2. And here we use the even property of trigonometric functions, of the cosine particularly, in order to solve this problem, right? We'll now work on question number 7, which says, given sine of t and cos of t, use identities to find the following 4 trigonometric ratios. They've given us the value of sine of t, which is 8 over 17, and cos of t is 15 over 17. So we have to now apply the different trigonometric ratios that we learned to find the value of the other functions. Now, we are not allowed to solve this in any other way but to use trigonometric identities, and you have to state which trigonometric identity you used to solve for a particular ratio. So tan of t, we apply the quotient identity, which is sine of t over cos of t. Tan of t equals sine of t over cos of t. So take the value of a sine of t given to us, 8 over 17, divided by cos of t is 15 over 17, and perform the fraction division. 8 over 17, change the division to a multiplication and flip the fraction in the denominator. That becomes 17 over 15. 17 and 17 divides, and we have 8 over 15 as the ratio for tan of t. And you have to state which identity you apply In this case, it was the quotient identity. Next, we have the cosecant of t. We apply the reciprocal identity for that because we know cosecant is the reciprocal of the sine function, and that means it's 1 divided by sine of t. So we have 1 in the numerator divided by, plug in the value of sine of t, which is 8 over 17, and that becomes 17 divided by 8. That's the ratio for cosecant of t, and please state that you've used the reciprocal identity to find this ratio. Secant of t is the reciprocal of the cosine function, so it's 1 divided by cosine of t equals 1 divided by, replace cosine of t by the value given to us, it's 15 divided by 17, so the answer is 17 over 15 for secant of t. Again, state it's the reciprocal identity that was applied here. And finally, cot of t. For cot of t, we can use either of two identities. One is the quotient identity, which is cot of t equals cos t divided by sine t, which is the reciprocal of sine t divided by cos t that we applied for the tangent function. So just plug in the values correctly. Cos of t is 15 over 17 and sine of t is 8 over 17. Therefore, when we perform this division, we end up with 15 over 8. We applied the quotient identity in this case, or we can just apply the reciprocal identity for cotangent, that is, cot is the reciprocal of the tangent function. Therefore, 1 divided by tan gives us 1 divided by 8 over 15 that we found in part A, and that gives us 15 over 8 for the ratio of cotangent of t. All right, so that is how you're going to apply the different trigonometric identities to find other identities when you're given the sine and the cosine ratios. All right. Question number 8 is about using the Pythagorean identity sine squared t plus cos squared t equals 1 to find cosine of t. Now they're asking us to assume that the angle t is between 0 radians and pi over 2 radians. They've given us the ratio for sine of t. Using this information and the Pythagorean identity, we will have to find the value of cos of t. First, write out the identity. Sine squared t plus cos squared t equals 1. And then solve for cos squared t first, because eventually we will be solving for cos of t. So we'll begin by solving for cos squared t first. That means move the sine squared t over to the other side and we get 1 minus sine squared t. Therefore, cos squared t equals 1 minus, plug in the ratio given to you into sine and write it as square root over 39 divided by 8 squared. The whole fraction is squared. And now perform the calculation. So cos squared t equals 1 minus. When you square root over 39, you get 39. You have to square the denominator as well. So 8 squared is 64. So we have 1 minus 39 over 64. When you complete the subtraction, you get 25 over 64. Now 25 over 64 is cos squared t. We have to find cos of t. How do we do that? By taking the square root of both sides, we can find cos of t. So cos of t will be equal to square root over 25 divided by 64. Again, you have to take the square root of both the numerator and the denominator. So square root over 25 is equal to 5 and square root over 64 is equal to 8. And that's how we end up with 5 over 8 for cos of t. Therefore, cos of t will be equal to 5 over 8. Right? We will now work on some problems where we'll find some trigonometric functions using reference angles. We cannot use a calculator for these questions. Question number 9 says, find the exact value of each trigonometric function without using a calculator. We have to first find the reference angle for the particular angle given and then find the trigonometric ratio. Now, what is a reference angle? A reference angle is found for angles in the second, third, and fourth quadrant. So if it's a second quadrant angle or a third or a fourth quadrant angle, then we find the reference angle for it, which essentially becomes a first quadrant angle, and then we find its ratio using the special angles table. Now this angle here is 5 pi over 4. First you have to figure out in which quadrant this angle lies. To determine in which quadrant 5 pi over 4 would fall, think about it. 4 pi over 4 is pi radians. So here is pi, here is 0, here is 3 pi over 2, then 0 is also 2 pi, and this is pi over 2, correct? So 4 pi over 4 would be pi radians. 5 pi over 4 is pi over 4 beyond pi, correct? So our angle would go in the positive or anti-clockwise direction. This is pi. You have to go another pi over 4 to form the angle. So this angle in the third quadrant is now 5 pi over 4. So what would be the reference angle for 5 pi over 4? Its reference angle would be this little angle here between the negative x-axis and the terminal side. So we have to find the measure for this green angle here between the negative x-axis and the terminal side. There's a formula to find the reference angles for every quadrant. For a third quadrant angle, the formula is take your angle measure, which is theta. In this case, let 5 pi over 4 be represented by theta. Theta minus pi, correct? If we subtract pi units from the entire 5 pi over 4, then we'll be left with this green portion of the angle. So theta minus pi, in other words, 5 pi over 4 minus pi will give us the reference angle. So let me mark that this is the reference angle. Reference angle for the third quadrant angle, 5 pi over 4. Once we find the reference angle, we will find the ratio of pi over 4, and then we have to remember to apply the appropriate sign that goes for that particular function and quadrant in which the angle lies. This is tangent. Remember the ASTC rule, ASTC. Tangent is positive in the third quadrant, therefore the ratio must be positive. So let's see how we've worked it out here. Tan of 5 pi over 4, it's a quadrant 3 angle, a third quadrant angle. And we also noted that tan is positive in quadrant 3. So at the end of the day, the final answer must be a positive ratio. Then we find the reference angle for the third quadrant angle. We use the formula theta minus pi, which is 5 pi over 4 minus pi equals pi over 4. So tan of 5 pi over 4 will be equal to tan of pi over 4. So even though this is a third quadrant angle, because tangent is positive in quadrant 3, therefore 5 pi over 4 will have a positive ratio, which is 1. And that is the final answer. All right. Now the next part is asking us to find cot of negative 5 pi over 4. So the angle given to us is a negative angle. We will pretty much follow the same process, except to find the reference angle of a negative angle, we first have to find the coterminal angle, and then once we find the coterminal angle, we will find the reference angle, and from there on we will use the reference angle to find the ratio. Now first is to determine in which quadrant negative 5 pi over 4 would be. Again, I'm going to draw here our xy axis. So negative 5 pi over 4 is an angle which will be formed by moving in the clockwise direction. Therefore, it's going to be an angle here going in the clockwise direction. Now, up to this point, this is pi. So, to get to 5 pi over 4, you will have to go pi over 4 radians over, and then this is where the angle will lie. So, this is a negative 5 pi over 4 radian angle. Now, to find the reference angle for this, let's try to understand where the reference angle would be. The reference angle would be this angle here, this green angle here. This is the reference angle. This is what we'll have to find. However, to use the formula for the reference angle for a second quadrant angle, we will have to find the coterminal angle. What is the coterminal angle? This is the positive coterminal angle. So this being the coterminal angle, that's going to be the next step. So far we have determined that negative 5 pi over 4 is a quadrant 2 angle. Cot is negative in quadrant 2. Therefore, the final answer will have to be negative because, again, by the ASTC rule, cot, which is the reciprocal of tan, will be negative in the second quadrant. So once we've determined the quadrant, we have to find the reference angle. The first step in finding the reference angle for negative angles, first find the coterminal angle. Now, 2 pi minus 5 pi over 4 is the formula. If it is a negative angle, then add 2 pi or multiples of 2 pi to find the positive coterminal angle. So 2 pi minus 5 pi over 4 is 3 pi over 4. So this angle here, this blue angle, which is the coterminal angle, it's 3 pi over 4. So now we will find the reference angle for 3 pi over 4, which is a quadrant 2 angle. We use the formula to find reference angle for a quadrant 2 angle. That formula is pi minus theta. So pi minus 3 pi over 4 is pi over 4. And now the last step is cot of negative 5 pi over 4 will be the same as cot of 3 pi over 4 will be equal to negative cot of the reference angle we just found, this angle here. So negative cot of pi over 4. Cot of pi over 4 is 1, and we have to add the negative sign to it, so we end up with negative 1. And as we said before, the ratio must be a negative ratio for the second quadrant angle, and that's what we have here. All right?